Hello, folks, and welcome to Rational Science. I'm in South America, and so I'm improvising a lot of stuff here. I hope you can hear me well, see me well. If not, please let me know in the comments section there. Okay. Anyways, I'm going to get started with the first half, which is usually about extinction, topics related to extinction, and then I'm going to continue with the second part, which is the lecture on physics. Today we're going to have a little look at energy. What in the world is energy? We use this word every day. Do we know what it is? Okay, so let's get started with the important stuff here. How much time we have on the clock before humans reach their dead end. Okay, and yeah, please let me know if you can't hear me or see me. Okay, so let's go with this. I had a bit of news, and it went like this: a virtual meeting that we had here with Mr. Biden and President of China, and it turns out that they were on Zoom. They were talking. I guess this is going to be the first time that presidents talk through Zoom at high levels, and they won't need to travel anymore. Well, that's good. I mean, I think we're going to be saving some money on trips. You know, Air Force One will be grounded, and they'll be talking through the internet, which is good in a way. You know, if they can resolve those issues by talking directly, why travel? You know, and even though they say that they missed, the personal contact, I think people will eventually get used to seeing this kind of stuff. Anyways, they had very low expectations for the meeting, first of all, and they made no major announcements, no joint statement. The United States talked about the Uyghurs, the Hong Kong, Taiwan. China says that's meddling in their internal affairs. Stopped them cold there. And then they talked about having a healthy competition and just leaving their differences in competition alone. To compete uh, fairly. According to the American side, they're not the Chinese are not competing fairly because I guess when they mention these things, they're saying in a way that people are compelled to work, more or less like they're slaves. It's like slave labor, that sort of thing. So they're insinuating that, and whenever the United States can, it will punish China for economically, right? Um, for uh, doing things inside their country which the United States considers against democratic values. And again, it's just a question of the Chinese saying, well, those are our affairs. Don't meddle in our internal affairs. And of course, they consider Taiwan an internal affair that the United States has no business getting into. Okay, it's like if China got involved into something happening, I don't know, in California or Kansas or New York, the United States would say that's our business, and so these are the issues. And that's on the Oriental side, way in the east. Here we have something a little closer by, and that's Russia. And apparently, there's already been according to this headline here, says that they've already started the Cold War again, or the World War III, you could say. It says war in space began on Sunday. Here's why the superpowers are on red alert. Okay, and what are they talking about? Well, they're talking about Russia having tested a, um, a killer satellite, something that kills satellite. Says is if a major superpower were to erupt, it will be in space. Satellites will stop working, screens will go blank, military communications will break down. Now imagine if that happened in the world today. No internet, essentially, right? That would be quite a problem because not only for military issues, but also for economic issues. Can you imagine the internet going down? Suddenly you don't have access to your bank account. Nobody knows how much money anybody has. you know, it says the testing of a Russian anti-satellite weapon this weekend caused a major stir. With no prior warning, a Russian space weapon was launched, traveled 300 miles above the Earth, and successfully obliterated a defunct Soviet-era spy satellite. The mess it has created signaled that Moscow can shoot down satellites in low Earth orbit if it so desires. Okay? So we're in a new era where we depend so heavily on the internet, especially military depend on it, economics depends on it, and now we can shoot those satellites down. And I'm sure the United States has that same capability if it's not developing it, right? And I'm sure soon China will also. And so the question is, if all these countries now have a chance or the opportunity, the ability to knock down the other guy's satellite, can there be a World War III? Where's it going to stop when these countries do not reach an agreement on things like Taiwan or Ukraine? Are they going to knock each other's satellites out? Is that what it's going to be? And once they knock them out, that's the end of communications. Except for the flat earthers. They believe all this is done through sardine cans, that you can talk through a can and that's connected through a little wire to the other guy on the other side, But for everybody else, it's going to be a big problem. Okay, fellow says here, says propaganda, fear porn for the Kool-Aid drinking masses that are dumbed down, lied to, fluoridated, programmed like a computer to stay lost and stuck in a matrix of lies and deception and blah, 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 blah. And he goes on talking about the government, the church, major corporations, media, Hollywood. Lots of people have this notion that out there, there are a group of people who govern the world. And, Illuminati, the New World Order people, whatever you want to call them. It's a group of rich people out there that allegedly or apparently, right, govern the world and have decision powers over millions of people. They can move things around because they have the money, the influence, the power, they have the connections, okay? And so a lot of people today fear or have this notion that someone in control out there, like moving pawns on a chess board, and they can do anything they want. And so a lot of people, when I talk about extinction, they bring these issues up, like, immediately they go into this Illuminati kind of thing. They say, well, it's the powers that be that govern and et cetera, et cetera. And they're going to take over the world. They're going to corral all people out there, keep them as slaves. They have these ideas. And all I can tell you is that, no, when the world collapses, when the global economy collapses, these people will have no power, because what's going to collapse is the money. So these people won't have any money, no way of influencing even their servants, whoever works for them now. Why would they work for these people what are they going to give them? Money? If there is no money and money is no more, what are you going to pay your servants with? So they won't have hitmen or anything like that, because they have no way of controlling them. In fact, they'd better fear their own hitmen, because their hitmen are probably going to take, vengeance maybe against them, saying, who are you now? So, this notion that the powers that be will corral people using the army or whatever, you got to control the army. The only way you control the army is by paying them. You can't pay the army. The army's going to rebel as well. So think about that, okay? What I'm saying is money will collapse. Money will be no more. And again, please let me know if you can't hear me or see me, okay? It's happened to me in the past where I talk and there's nothing there. Okay, here's another comment. Fellow says, contributors to this inflationary cycle. We talked about inflation the other day. The climate agenda of the government has chilled new oil production with excessive regulations and taxes, inflating gas and oil prices. 25% of gas and oil is used for plastics and fertilizers. He mentioned a couple more. Cooling climate and crop losses contributing to inflation of food prices. Starvation will reduce world population. Uh-huh. I'm not sure about that one. Starvation really today kills a few people in some country in the world, and I'm being kind when I say few, maybe a few thousand, maybe even a million. That could happen, but that's not going to have an impact on the global economy. The global economy will collapse only when you have full-fledged starvation. Then you have a problem. But if one country, a very poor country, has some people starving out there in the wild because they lived in the country and they have nothing to eat, that's not going to affect the world economy. So there's going to be no decrease in population. There's going to be an increase in population until the economy collapses. Once the economy collapses, oh yeah, then you'll have a very sharp decrease in population. Because of what? Because of starvation. Okay, so anyways, that's my take on that. Manipulated lockdown, shutdown, just-in-time delivery of goods, cheaper prices for the consumer, created shortages. Unemployment due to manipulated unemployment payments. In other words, subsidies, reducing production. Yeah, there's a lot of that going on today. I don't know if we're going to come out of that, because one of the issues that I mentioned the other day is that there's like 10 million jobs in the United States available, and not enough people to take them, because apparently people have something better to do with their time than work for minimum wage. So maybe they live with their parents, they live with their wives, whatever, and make maybe a little money on the side, and that's enough for them to live without having to work. So keep that in mind. That work is now not desirable as it used to be in the old days. Okay, especially at such low wages. If they double the money, the amount of money they're going to give you your salary, you might decide to work. But with the way things are right now, salaries are so depressed that a lot of people decide not to work because they find other ways of living. Okay, and it doesn't mean they're going to be rich or live, throwing butter up in the air, but they can live and they can just make it to the end of the month somehow. They're not going to find a job. They're not going to look for a job. And the end result will be stagflation. Okay, there's an opinion for you. I think inflation is going to be a problem. There are many factors affecting inflation, like this fellow says. But I think it's inflation that's going to eat into the salaries. And right now, the salaries are quite depressed. I mean, in real terms, right? And inflation is going to eat into that. If the government doesn't somehow raise minimum wages significantly, or companies don't raise their workers' salaries significantly, there's going to be a problem. Because a lot of people from the middle class will be falling into the poor class, and meaning that they can barely make it to the end of the month. Some maybe not make it to the end of the month. Those people are going to go out into the streets and break windows and burn tires. Okay, it's just that revolution, grassroots revolution kind of thing. French Revolution, Russian Revolution, that sort of thing. That's very likely to happen even in advanced countries. People say, no, that'll never happen. In Germany, they told me, no, that won't happen. The food lines, the soup kitchens, get ready for them. Okay, regarding homosexuality, that we raised the topic the other day, fellow says, sex hormones start with a base molecule of cholesterol. Maybe replacing animal fats with vegetable oils has contributed to the homo expression, okay? Ironically, saturated fat assists the liver in breaking down toxins that also may contribute to homo expression. Eat your butter and make sure it is real. Okay, what can I say? I'm going to argue that it has nothing to do with food, even though food in some way maybe affects the sex. Uh, I think sex, I mean, especially orientation, right, is 150% how you're born. Okay, it's in your genes. Okay, and no one decides one day says, well, I'm not going to look at girls anymore. I think I'm going to look at men. It doesn't work that way. I don't think it does. I think you're born with that orientation. You can't do anything about it. Okay, whether it's nice or not, that's a separate issue. But I'm saying that I think these people are born that way. I don't think any no different than heterosexual. He's not going to come out one day and say, well, I think I'm going to like men now. No, it doesn't happen. You don't change your orientation overnight because you were beaten or because your mother educated the wrong way or your father hit you or whatever. I don't believe that. You're born with it, period. Okay. Another fella says homosexuality might be a spin-off in the pursuit against the path of least resistance. Whoa, what is this about? Whether it's a successful approach remains to be seen. For example, homosexuals exposed to the HIV who somehow acquired natural immunity would now be favorable to the species for their enhancement of genetic diversity. In other words, he's saying that if the guy survives that, he's gone through this sifter, HIV in this case, in this example, and so now he's got a different genetic code that, I guess contributes to humanity, to the fact that we have better resistance, the next generation has better resistance because this guy survived, that sort of thing. Were they also able to survive other unique diseases, exposure in that lifestyle? Okay, hello? Just let me know if you can't hear me or see me, okay? I'm worried about that because, again, I'm in South America and I'm improvising a lot of this stuff. I hope it comes out all right. Anyways, were they also able to survive other unique diseases, exposures in that lifestyle, and eventually have children? You could consider that spin-off to be sustaining said life a bit longer. Yeah, again, you're preaching to the wrong guy here. I'm saying all this stuff has to do with evolution and the fact that we've intermarried for so long. Here, let me show you a little picture that I made here just to give you my peace of mind, my 10 cents worth. Okay, here it is. This is what happened as far as I'm concerned. We had, for millions of years we were evolving, and then maybe 200,000 years ago, you could say our species began or came into being in the sense that we could trace our lineage to about 200, maybe 300,000 years ago, and we could still mate with whoever lived in those days, about that time. If you go farther back, maybe to 500,000, 600, 700,000 years ago, we would not be able to mate and have successful children with anyone in those days. So that's what I call the beginning of the human race, anywhere between 200,000, 300,000 years ago. Okay, since then, we've been inbreeding. We've been breeding only with our own kind. We did not breed with the Denisovans. We did not breed with Neanderthals or any other species on the planet. Essentially, we inbred. And we've been doing that for maybe 200, 300,000 years. And now we're having genetic problems of all kinds, physical and mental. And I think that this homosexuality thing is one of the mental variations that we have today, thanks to the fact that we've been inbreeding for 200,000 years. At some point you're going to have problems. And here, let me present a little bit of proof, okay, evidence for those people who rely on proof and evidence. Okay, here's which is unscientific, by the way. It's just part of religion. It's just convincing, persuading. Okay, that's what I'm going to be doing now. And here it is. You find the gay Mennonites. Okay, and you go to the Atlantic magazine there. And here's this article from 2015. You'll find a lot others, okay, out there. It says the denomination has gone through many schisms. They're talking about the Mennonites here, which is a branch that came out of the Amish and all these people who came in the 17th century to the United States, right? Often over issues of tradition and modernity. At one time, it was buttons versus eye hooks on blouses, and whether women should have to wear bonnets. That was in the old days. But today, more recently, it's been women's leadership in the church. You have some women who are pastors or leaders in the Mennonite church. Unheard of, unthought of, unimaginable. And acceptance of those who identify as LGBTQ, XYZ, and so on. Yeah, all these problems are new in that religion, and they are also in the Amish. Here's the Amish. Okay, let me give you a couple pieces of evidence here. One is one site that says the counseling center, and the guy has a blog on on how he became or he was born. He says he I guess at the age of 14 he realized he was homosexual. Okay, so I guess they kick him out. They say, look, you either marry a woman, have 10 children like all Amish have, or you get out of here. And another group formed this, what is it, the LGBT Amish, okay? A site for all those who are kicked out of the Amish church or religion, and they have nowhere to go because they are homosexual. And so this is what that's about. So you got that LGBT with a horse. Okay, so these old religions, they're having problems. Why? Because they have the same problems that we have, like they call it the English world, the world outside their frontiers. They're experiencing the same type of problems that we are in our normal world, you could say, right? And why? Because they've been inbreeding for the last 400 years, maybe. So this gives you something to think about. They've been inbreeding. Today, they're having physical problems after so many years of inbreeding. They're having a lot of mental problems, and one of those aspects is homosexuality. Okay, so you should look at all these cases, because I'm saying that again, it's got to do with inbreeding. The fact that you cannot inbreed any species, or at least many species. I can't say all species, but many species. If they inbreed for thousands and thousands and thousands of years, at some point they're going to have physical and or mental problems. And you see that there are lions who they are homosexual. You see the male lion mounting another male lion. You can interpret that any way you want and say, well, this is this is that. Yeah, whatever you want to say. We see it on sheep. And sheep are a little different than lions, and nevertheless, they both are mammals, and they both have homosexuality. About 10% of sheep are homosexuals. And like I said the other day, they did cross sections of the brains of sheep, and they found that, the homosexual ones have different brains than the heterosexual ones. So you figure out. Okay, so let's move on to subject of today, which is energy. And I'm going to start with where I left off the other day, which was weight, work, and then we move on to energy. And Appel raised an issue, and he says the following. He says, so-and-so on Quora explains that the moon doesn't weigh anything because it is in free fall. I was saying that you do not need contact. You do not need to put the ball or the box or whatever you put, the pyramid, on a scale. Make contact with a scale in order to have weight. In order to say, oh, now the sphere, the box has weight. No, the box had weight even before you put it on the scale. But this fellow believes that you need contact, that there has to be surface-to-surface contact in order for there to be weight. There has to be this pressure between two surfaces. Okay? And I'm saying, no, you don't. And let's show why he's mistaken. Okay? And here you see where all this comes from. It comes from Mr. Einstein. Okay? And Mr. Einstein in 1907, the time he was developing special relativity, he came up with this notion that a person falling, like in an elevator, is someone cut the ropes and the guy's just falling, or falling from an airplane. For him, it's like being in space. He doesn't feel his weight. Okay, so we have this notion today. Objects in free fall do not experience being accelerated downwards, okay, like, for example, toward the earth or other massive body, but rather weightlessness and no acceleration. Okay? But we have a problem because weight is a gravitational phenomenon. It's defined that way. Weight is equal force acting on the object due to gravity. So do I need a scale to press upon in order to have gravity? Or is there gravity? Or does every object in the universe have gravity? Here, let me show you. Okay, here's a pictorial way of looking at this. Okay, and you can see that everything is interconnected in the universe. Electric universe calls them filaments. Okay, and what you see is that all galaxies, stars, and everything is really connected. They're connected in some way. Okay, physically connected out there. And everything has gravity with respect to everything else. Okay, so this notion that you need contact is wrong. You had weight before you fell to earth. Okay, that's my take on this. I'm saying that everything has weight. You don't know the value because that doesn't matter. What matters is the definition of the word weight, which is a gravitational phenomenon, and everything in the universe, which is an object thing, okay, usually a celestial object of some kind, is gravitationally attracted to everything else because everything is physically connected. Okay, everything is interconnected. Everything in the universe, all matter is interconnected. Also shows that Mach's principle, that when you twirl around, looks like, being pulled by the stars. Yeah, correct. That's what you're pulling against, in a way. Okay? So everything is connected. You don't need to weigh yourself in order to have weight, because weight is not defined as a contact force. Weight is defined as a gravitational influence of some kind. Okay? And I'm saying that you have weight when you fall to earth. But what Einstein was talking about, and again, it shows the mentality of the mathematicians, he was talking about feeling, what you feel. We don't care what you feel. There are no observers in science. There are no observers in physics. In physics, you have weight, whether you observed or not. The moon has weight, whether it touches something or not. The moon has weight because it's attracted by the earth. Somehow, we say all the atoms there are connected, physically connected to the earth, and the earth swings the moon around. And this is what's happening, okay? My hand is going to be the earth, and this is what's happening. Why? Because the moon is every atom. Here I have only one string, but every atom in the moon is connected to every atom of the earth. That's why the earth swings the moon around. Space is nothing, so it has nothing. The moon has nothing to scrape its shoulder against. There's no friction. That's why the moon just rolls around and around and around, and the earth rolls around the sun for the same reason. Every atom on the earth is connected to every atom that makes up the sun, and the sun swings the earth around and the moon and the rest of the planets without any friction. That's what's happening. And yeah, we call that gravity because otherwise the earth would fly away. And yeah, there is gravity. The earth has weight, and it's called weight, okay, not mass. Okay, mass is the quantity of matter. We don't count the quantity of matter of the earth or of the moon. We say it weighs so much, and you give the value in kilograms, okay, or pounds or whatever. And that's weight. And you say, well, yeah, because we use mass and weight and mass and weight. Yeah, this is the problem. There is no difference between mass and weight. But these people want to give you the idea that there is a difference. There ain't no difference. Mass and weight are the same thing because they never have been determined in any other way other than through weighing, through contact weighing, which is what this fellow is talking about. But that's not what it is in physics. In physics, we care about the mechanism. And the mechanism, again, everything is connected, therefore everything has gravity, which is a falling of something towards another where the ropes fan out. And the reason the earth doesn't fall to the sun or the moon towards the earth is because it's being swung around. So you have centripetal motion and you have centrifugal motion. They cancel each other out. This guy rolls and rolls around, and there's nothing to stop it because there's no friction with space, because space is nothing. Nothing is that which doesn't have shape. That's the way it works. Now we can talk intelligently about these things. Okay, okay, here's what energy looks like. Okay, we're going to talk about energy. I want you to, right up front, I'm going to tell you what it looks like. This is energy. You've seen it here, okay, for the first time. Here it is. That's energy. Okay? So if you ever want to know what energy looks like, there it is. Okay? We have energy. Okay, so I guess the lecture is over. There you see it. We wanted to show you what energy is. There you see it. Nothing more to say, right? Okay, but there's a little bit of a problem. Here we have a fellow, and he says the following. He says, energy is an object. Okay, that's what I showed. Something. There was something there. Whatever it was, there was contrast, there was shape. It was moving. Okay, I showed it to you in motion, but there's something there. There's contrast. Something in motion, that's a something, right? Even though it's in motion, it has to be a something to be in motion. Okay, and I showed you something. Some smoke, some spirit, some whatever you want to call it. That was energy. Okay, and he says it is the deltas between frames. What is a delta? Delta is not a physical object. Delta is a letter. That's what it is. Delta could be a difference. I don't know what delta is. Okay? But then he says energy is the capacity for work. Well, if energy is the capacity, it's not an object. But see, these people just use these words without ever defining them. They don't define the word object. So they can say, yeah, energy is an object. Energy is A. Energy is B. Energy is C, as long as he doesn't define A, B, or C. He can say whatever. He's got to start by defining object. And if object has shape, you can't say that capacity has shape. Because if energy is a capacity, it can't be an object. And if it's an object, it can't be a capacity. That's how simple it is. But then he says, not any matter, chance, or work itself. So, yeah, if it's not matter, then what is it? It's a concept. Okay, so, yeah, you can't talk about transferring of concepts. Okay, so here you have a guy a little smarter than this guy. His name was Richard Feynman, and he says, it is important to realize that in physics today we have no knowledge of what energy is. What Feynman didn't realize was that energy is not a what. What is what we call a shape. In other words, a what is a thing, a substance, an entity, something, object, whatever those words you want to use. Okay, it's that which has shape. That's what a what is. So you can't say what is energy because it's an irrational question. Energy is not a what. Energy is a concept. Concepts are the opposite of objects. Not really an opposite, but they're in a different category. Okay, it's either an object or a concept. Either you have shape or you don't have shape. If you don't have shape, you're a concept. That's how simple it is. So every word in the dictionary falls under one of those two categories. Either object has shape or concept doesn't have shape. In fact, the word concept is really a relationship between two objects. That's what we invented, all concepts. Okay, so God has to choose whether he's an object or a concept. If he wants to be an object, be the guy who waves the magic wand and makes things appear, fine. He's an object. But God cannot also be intelligence and love and all these other concepts. Okay? Okay, and here's the punchline on that. Yeah, you can't, energy is not a what? Energy is a concept. Okay? In fact, the fact that you define something like energy, in other words, this word, if it's defined, it's a concept. Because objects we don't define. Well, you can't define an object. You can't define the word table. Okay? You point to a table, then you describe it. But first you have to point. That's how we designate objects in physics, in science. And you can't point to energy. What are you going to point to? That smoke that I showed you a little bit ago? Okay, so energy, again, is the capacity, the ability. Those are concepts. There's no physical standalone object called the capacity. Okay, so you can't transfer the capacity. What are you going to transfer? Okay, so concepts have no shape or location and therefore do not move. You cannot move love because love is not a physical object that I can show you. love would have to have shape. And then I could move it around, kick it, whatever. I could show you love in motion. I can't do that because, it's not a physical object. And so people introduce these words of ordinary speech and they say, look, love, I can transfer love. I can transfer energy. No, before you can talk about transferring something, you have to show the picture of the thing that you're going to transfer for the purposes of physics. Then you can say, look, I'm going to show you how the ball is transferred from A to B. I can do that with a ball. I can do that with this. Okay. Here I can say, here's at A and here's at B. That I can do. How do you do that with a concept? What are you going to move? What are you going to see? Okay. And so this is where the problem is. These people never define the terms, especially the word object, which is the one that kills all religions. Okay. Concepts cannot be transferred from A to B. And there you have energy. Just a word that's being transferred. Is that what it is? Okay, so no, you can't introduce terms of ordinary speech or notions of ordinary speech into physics. And physics is literal. And in order for it to be literal, you have to have the object. You have to have the ball. You have to have the square, the cube. Okay, you need to have something. Then you can talk about motion, because the only thing that can move is an object, a thing. Okay, you can't say that you're going to transfer energy, transfer love, transfer intelligence, transfer grace. You can't transfer concepts. But this is how these people talk, and that's what they have in their tiny minds. So they talk that way. Okay, they're religious people in the end. I call them spiritualists because they move concepts around. In the old days, they moved spirits. Why? Because they couldn't see all these mechanisms that Mother Nature has, all these mediators that are invisible and intangible. So they invented this spirit. And it's these people who have taken over mathematics and teach so-called mathematical physics to the new generations. And they learn the same words, but the words are now different. They're called energy. They're called weight. They're called vortex, ether, field, and energy and mass. They have all these terms that they move around, and all those are concepts. You can't move concepts around. First, you have to have an object in order to conceptualize motion. What is motion? Two or more locations of what? An object. It has to be an object. What is an object? Shape. You have to have, it's that which has shape. Then you can be rational. You can talk sensibly. You cannot introduce concepts as objects in physics. Okay, and so the other day we covered work, okay, and it turns out it's associated with this famous word called energy, okay? Anything that is capable of performing work possesses energy. Possesses energy. You mean possess like I possess 2 coins in my pocket? Is that how it possesses energy? Is energy a thing that you can put in your pocket, hold in your hand, throw away? Is that what energy is? Something like that? Energy represents potential work. Okay? So there's this mysterious whatever. We're going to call it energy, X, Z, whatever you want to call it. And now what we're going to be doing is doing work with that. What was work? Well, we talked about that the other day. Work is what? Force applied over a distance traveled. And if you just have that, then you're moving something horizontally, which you see at the bottom. And that's, if the full equation is with times cosine of A. If A is 1, then you have horizontal work. But if you move it up and down, then the question is whether you can use this equation or you have to use the gravitational equation, because you're pulling the box against gravity or dropping it towards gravity, whichever, it doesn't really matter. But you're going vertically with respect to an axis that goes through the center of the Earth. So you're talking about up and down, and you're going to be talking about gravity, pulling or pushing against gravity. Now you have to use the gravitational equation. And then it gets more complicated when you get on any inclined plane, because now you have the 2 components, the horizontal and the vertical component. And again, the way the mathematicians figured it out, they said, we're going to just use cosines, which is, trigonometric accounting system. That's all it is. But we're not learning with that what is physically occurring. See, if gravity is involved in this situation, then you have to factor what? The fact that no matter whether you use horizontally or up and down or inclined, in an inclined plane, what you have is every rope from every atom that forms the object that you're moving in any direction is tied to every atom on Earth. You have to factor that in, and that's physics, because now you can see what's happening physically. You can't do that if you put cosine of A. Cosine of A is just an accounting procedure for describing. It doesn't give you any insight into how gravity works or what work really is. Okay? But again, anything that is capable of performing work is what they call energy. Okay, so now we're approximating a definition, you could say, okay, or at least a notion of what energy is. But here's a clarification: a man standing with a box on his shoulder, right, like this, okay, is not doing any mechanical work. If you're just holding the box there, okay, you're not doing any mechanical work. Nothing is in motion. You're just standing there with a box there, okay? And even though the task tires him, if you have a big box, you're going to get tired, right? But you haven't done any mechanical work. The box could be supported equally well by the floor with no expenditure of energy. So I could put that same box on the floor. There's no expenditure of energy, but we still seem to have some expenditure of energy in there, because it's called, well, not expenditure, but we have some energy that is stored. And they call that potential energy, okay? A situation which does not require the expenditure of energy can't be regarded as work. So we don't have work, but we have energy, okay? So we got to find out what this energy, mysterious thing called energy is, okay? Let's find out. Let's see if we can get to the bottom of it. Okay, so here we have a couple of people who addressed it. Remember, in the 19th century, it was the age of manufacturing. And they had the steam engines built. They built trains, all these cabooses. They had cars. Eventually, beginning of the 20th century, they came up with airplanes. And so, they were developing engines. So they were very concerned about this mysterious thing called energy. So energy was studied, whatever that was. It was studied in great deal by a lot of researchers. And they were trying to get to the bottom of it. But what were they trying to do? They were trying to do math. That's where the problem is. They were doing mathematics, not physics. They were doing experiments out there and then measuring and then coming up with equations. Well, that gave them a description. It did not give them an insight into what was causing this thing, and they call that unknown energy. And so the word energy entered the lexicon very strongly in the 19th century. It was there before then, right? But today everybody talks about energy because it's the word that you can fit in anywhere you want. It's the wild card, so to speak. The joker in the rummy game, you can use it as any card you want. You just say energy and you're done. And nobody's going to question it because nobody knows what energy is. Why? Because it hasn't been defined. And second, no one knows if it's an object or a concept. There's all these problems. And everybody says, well, we don't care. That's just semantics. That's not physics. Physics is doing an experiment and measuring and giving you an equation. That's physics. Well, we beg to differ, okay? No. And so here we have one fellow, and this was Julius Meyer, German guy, and he came up with this first law of thermodynamics. I guess his thermos was rolling, and he said, oh, thermodynamics, thermodynamics. And so what did they came up with this equation. It says change in the internal energy is equal to energy added to heating and minus energy lost due to work. That's in general terms what this first law of thermodynamics stands for. Okay, and what does it mean in you could say in physical terms, because this is not even physical. Again, it's just a description. It says the total energy of an isolated system is constant. It's got to be a closed system, okay? And energy can be transformed from one form to another. For example, potential or chemical energy to kinetic energy. But what are they talking about? They're talking about accounting. All they're saying is we take energy over here and we turn it into a different type of energy over here. But what do we mean by that? Are we turning smoke into a solid rock? Is that what energy is? And no, the issue is that it's just an accounting procedure. It's saying, look, this part of the equation turns into that part of the equation because we go from potential to kinetic energy. Just a different type of aspect of this unknown called energy, undefined word called energy. The spirit turns from black to white, but we don't know what the spirit is, so to speak. That's more or less the situation. But can be neither created nor destroyed. Yeah, you can't destroy a concept. We tried to destroy concepts and it's very hard. You can't destroy distance. You can't destroy thought. You can't break the guy's head, then you can destroy thought. But you can't destroy concepts. You can destroy a chair. You can destroy a tree, a rock, a dog, things you can destroy. You can destroy a house. But you can't destroy a concept. What do you mean destroy a concept? How do you rip it? I mean, physically, we're talking about physics here, right? We're not talking about math. Can you rip a concept? Can you rip love? Can you rip grace? Can you rip intelligence? Can you pound it and say, I'm going to hit intelligence? You can hit the head, which kills the processes we call intelligence. But can you get intelligence out here and bang it and break it into pieces? So yeah, you can't create nor destroy energy because, it's nonsense to talk like this because energy is a concept. And yes, it makes no sense to say that you can, create or destroy energy. But it didn't stop there. Here you had another fellow. He came a few years later, also German. His name is Rudolf Clausius. And he came up with the second law, or started the second law of thermodynamics. And again, here you have the change in entropy. My God, what is entropy? Change in entropy is what? Equal to change in the heat transfer within the system, right? Divided by the environmental temperature that you have out there. Okay, so you can see that all these people were working on equations. Why? Because they were interested in technology. That's what they were working on. They were doing experiments to understand this mysterious thing we call energy and how it works. And so they developed equations. What are equations? Descriptions. That's all they are. We have no explanation so far. First law, second law, whatever those laws are, we have no explanation of anything. All we have is a mathematical description. That's what these two so-called laws are. And that's what the mathematicians call them. They call them laws because it's a pattern, it's a repeatable pattern that they can measure repeatably, and they call that science because you can measure the table repeatably. So you measured the table 1 meter. The other guy comes over and says, no, I measured it a little better. 1 meter, 1 millimeter. Aha. And the other guy said, no, you're wrong too. It's 1 meter, 1 millimeter, and 1 micrometer that I was able to measure. And so now you measured more accurately. And the other guy comes with a ruler, he confirms that, I say, oh, repeatable reading. The other guy comes in and says, I repeated it too. So it's 1 meter, 1 millimeter, and 1 micrometer. That's how much the table measures. And they call it a law. The law of the table. Is that what science is? Just measuring and giving you an equation, giving you a bunch of numbers and units, and calling them laws, the laws of God, I guess? I don't know. Is that what science is about? Or is science explaining how Mother Nature runs this universe? That's what we want to know, understand. Okay, so here we go. How energy is used. This is, again, remember, this is 19th century, okay, primarily. This is when a lot of this stuff, all the engines were being developed, okay. The criterion by which energy is recognized as such is its ability to be transformed into work. Okay, you got to turn that into work, otherwise it's useless. But what are we talking about? This is technology. What does this have to do with understanding how the universe works, which is physics? This has to do with just describing a mechanical thing that works there, like a car works, how much energy you need, how much gas you need. They call that energy as well, So you need so much gas and it lasts so long if you run the motor at so much speed, etc., etc., etc. That's all technology. We still don't know what this energy spirit is. That's the issue. To use energy and say, oh, you put energy in your tank. Well, no, I put gas in my tank. Okay, so what is this energy that's being transformed? Are we transforming the gas into what? Into motion? Is that what it is? Again, it's easy to use this word energy whenever you can't fill in the blanks, and that's what these people do. It says, any body in motion possesses energy. Okay, what is energy? I mean, I possess it, great. Sometimes I don't have energy, but I guess I possess energy, whatever it is. I need to know what that energy is before, before I can use the word possess. Is it the same thing as possessing a dime in my pocket? Is that how you possess energy? Can we use that language in physics, what these people are using here? The energy of a moving body is called what? Kinetic energy. Kinetic referring to motion. Okay, but that's not the only type. There's another one. There are more kinds, but these are the main ones. Potential energy. An elevated body can also do work. It can acquire increasing speed. That is, kinetic energy when falling. The energy of an elevated body is called potential energy. Okay, so we have kinetic energy, which is energy of motion, and we have potential energy, static energy ready to be used for something. And again, all this has to do with technology. It has nothing at all to do with how the universe works. Okay, because you can't explain how the universe works using the word energy. Energy is a word of religion because first it's undefined. Then people say they don't know what it is. Then they don't know if it's a what, meaning a thing, or a concept. But they use it anyways. And anyone who attacks their sacred word is, heretic. and you're trying to kill their religion, and they say, you're doing semantics. You're just doing semantics. That's not physics. That's the way they handle it because they have no answers. Because they have no idea, like Feynman said there, they have no idea what energy is. And if Einstein, who had a Nobel Prize, could not tell the difference between an object and a concept, what can you expect with all these bozos that, that just dabble a little bit in so-called physics? They get into the mathematical physics, you wonder why they don't just go to church and pray. Because these are all religious people. Anyone using the word energy is a religious fanatic. That's all he is. He's trying to he wants to keep that word energy because without it, his entire religion is lost. So energy is an extremely important word for them. You can't attack it because you're attacking their God. You're raping their virgin. Okay? This is the issue. Okay, so here we have a little gift that shows that you can change one type of energy into another. You have potential energy at the top, and as you drop the ball, it loses potential energy, and you convert that into kinetic energy. So what transformation happened here? I mean, can you please tell me what changed into what? Did a dog turn into a cat? Is that what they're saying? Is this what we're talking about? It says when an object falls, it loses potential energy and gains kinetic energy. Gains, you acquire. Okay? And the increase in kinetic energy is exactly compensated by the decrease in potential energy. What did we learn? This is an accounting procedure. This is, you have your bank account, and you take money out of your assets and put it in the debit. And so you change your money from one type to another, from plus blue to red negative. Is this what this is? Potential to kinetic energy? What has changed here? What understanding can you get from potential being changed into kinetic or chemical to kinetic or whatever? What understanding do we have? I mean, the equation, you can even memorize and write the equation and pass the test. Say, well, you have so much potential energy, change to kinetic energy, and here's the equation that shows the transformation. Those are all descriptions. Just, joules turned into a different type of joules, maybe. What is that? That's nothing. We still have no idea what energy is it. Is it a cloud like I showed earlier, some kind of smoke that's out there? Is it a spirit? What are we talking about? What has changed? Has the form of the energy changed? Again, did the dog turn into a cat? Did this smoke turn into a different type of smoke? Did it change its color? This is the issue. The issue is that this is not physics. saying, using the word energy, or saying that you change one energy into another type of energy. You're not explaining the mechanism, what's happened, what's changed. All you're doing is describing something, not explaining what's going on in that invisible world. And the only way you're going to explain it is making that energy visible and finding out what it really is, if it is a what. If it is a what, and you have something physical, then you can say this changed into that, change its form. Or it changed its structure, it went from solid to liquid or something like that. And you can show what happened. And not describe it mathematically, but show exactly what changed. And then for that, you don't need the word energy. All you say, the dog turned into a cat. Then we all understand. It's very simple. You say the tree turned into a house. We can all understand that because we see the tree here. There was some manufacturing going on. It turned into a house. You see the dog here. There's some voodoo magic, whatever, and you turned it into a cat. Great. We all understand that. But to say that potential energy turned into kinetic energy, that's just an accounting procedure. That's your money from the assets to the liabilities. That's all it is. Okay, and since all these people did math, Einstein didn't stay behind, and he came up with this. Apparently, he's credited with it. I have my doubts that he was the originator of this equation because they were already dealing with this kind of equation before then. Whether he was the one that really came up with it, I think you could say that it was like a group thing where several people already had these notions. Maybe he was the first one to formalize it. In that sense, yeah, he probably gets the credit. But anyways, it says E equals mc squared. Great equation. Everybody just repeats it. Nobody understands what it means, but I mean in real physical terms. But everybody knows how to say that. Oh, E equals mc squared. And they say that's Einstein. They all know that. And that's Einstein's equation. Okay, but we had a problem. We don't know if it's mass or weight. And you say, Bill, it's mass. See, it's the little m. It says mass. Well, yeah, but we have this energy and special relativity where if the thing travels near the speed of light, it gains mass. Well, did it gain quantity of matter, which is the notion we have of mass, or is it pressing harder and harder against the scale, meaning its weight, right? So maybe it's weight times velocity of light squared. Maybe that's what they're talking about. Okay, or is there a difference between mass and weight? And then velocity of light or speed of light. Is that little c velocity or speed? What's the difference? Velocity has direction. Speed only has magnitude. It's a scalar. And so those are the first things you got to clarify. Then you got to clarify the other thing is, can a photon move in circles? One photon. Okay, cannot move in circles. I don't know how you would draw the wave. You got a pinpoint wave and it's moving around, maybe a wave packet, I guess, I don't know. Chop it off. At the ends, you have this little wavy thing and it moves around in circles. Can one photon move around in circles? Around nothing, or even around something, I don't care. Can it move in circles? Okay, so these are the things you have to look at because if it moves in circles, you're changing the direction. And like we held in a couple lectures ago, if you change the direction, you're changing the speed. But they're saying, oh no, we don't change the speed, we're changing the direction. Okay, but we have a problem with that because if you change direction, you have the centripetal force and the centrifugal force, they're canceling out, and that's why this thing is going around in circles. So you have an acceleration, which is known as centripetal force. That's an acceleration. And what they do is instead of talking about the centripetal force that's pulling, that's tugging against the centrifugal motion, or force caused by the motion of something going around, it's being canceled, but it's still being pulled. Okay, it's this. Okay, that's what it is. You swing it around, okay, and you have both centripetal acceleration going in. There is an acceleration whenever something moves in circles. And so does light accelerate and just change directions? Is light being pulled from some center, like if it went around the sun? Can a photon travel in circles? So yeah, we have all these issues, but again, all equations, that's all they have. E equals mc squared, great. He gets a Nobel, he says, for that. I mean, he didn't get it for that. He got it for the photoelectric effect. But yeah, they could have given him a Nobel for E equals mc squared. What is that? That's a description. What have we learned? What have we learned about how the universe works? That's what I'm talking about. What have we learned about, what gravity is? What have we learned about what, light is, or what magnetism is? Those are the things people want to understand. And, you're not going to get them through equations. Okay, so here are my conclusions for today. Conclusions: energy is not a thing. There's no thing, no object, no entity called energy. No standalone thing that I can bring to you like this. I bring this ball to you and say, this is a ball. I can't do that with energy. Say, look, this is energy. This is a field. This is a wave. Transverse wave, right? This is a field. Two fields make a wave, This is time. I can't bring time and say, look, this is time. I'll show it to you. No, because for that it would have to have shape. Then you would say, then you could present it like that. But you can't do that with energy. So energy is not a thing because you cannot present it like that. Therefore, you can't use it in physics as a physical object, and therefore you cannot say that you're going to transfer energy, because you can only, in physics it's literal. I can transfer the ball from A to B. Here it is. I transferred the ball. That's called transferring the ball. I can't do that with energy. I can't say I transferred the energy. What have I transferred? I haven't seen it. Please make it visible. You need to make it visible, and for that, energy would have to have shape. Okay, and energy does not have shape. So you can't use it for mechanisms. What is a mechanism? Mechanism, what we do in physics. We do a physical interpretation. That's what physics is about. You need to give a physical interpretation of how something happened. Okay, and you can't use it for, you can't do that with energy, because you would have to show it first. First step is you got to show energy, point to it. And then you can say, okay, now I'm going to do this with that thing I called energy. Then you can do that. But first you got to point to it. For that, it has to have shape. You should be able to draw it. If you can't draw energy, you can't use the word. Not as an object. Not in physics. Okay? Energy, it turns out that even as a concept, it's undefined. There is no definition of the word energy. We have no definition of the word energy today. Okay? Because they have like 7 different types of energies. And they have potential energy, chemical energy, and kinetic energy, and who knows what else. They have all these energies out there, okay? And what are they? They're just equations. It's just like E equals mc squared. That's it. That's energy. The definition is what's on the other side of the equal sign: mass times velocity of light squared, or maybe it's weight times speed of light squared. Who knows, And then again, that squared gives you an idea. It's just an equation. That's not a definition. Okay? That's just an equation. That's a description that they're going to use in mathematics. Okay? We don't have a definition written out, because whatever you write out is wrong. They have 10 different types, and they use all 10 simultaneously. And then energy is a mathematical concept. So what is it? It's a spirit. It's the same word as spirit in the old traditional religions. No different than the word spirit. It's religious people who have taken over so-called physics. It's known as mathematical physics, also known as science. That's the people who run it, are religious people. They're people who memorize, pass their test at the university, get their PhDs, and then they just blab the same thing over and over to the next generation. We've been doing that for 400 years now. And essentially, energy is a wild card. Whenever you're ignorant, whenever you don't know anything, you say energy, and people say, he's so intelligent. He used the word energy. Okay, that's what it is, a joker in a rummy game. That's what energy is. Okay, let's go with some of the questions people had or comments that people made this week. And we have a first fellow. He says, you said before the universe never had a beginning. What about entropy then? Yeah, what about it? I mean, I don't know what this guy, what's your question? I mean, he said, what about entropy? Yeah, what about it? I mean, what does entropy have to do with the beginning of the universe? We're talking about, the creation of matter from absolutely nothing. And it's not even that because Big Bang created nothing as well. Created something and nothing. That's the official version. It created space and matter. So it created nothing and something. What was there before then? You can't say nothing because that was created at the Big Bang. So again, a Big Bang is an irrational theory. It's a creationist theory. The traditional religions at least have a better explanation. They say God made it. Moved his magic wand and said abracadabra, and Big Bang started. That we can all understand. What we won't understand is who made God. And they say, well, he's eternal. They have different answers to that. Okay, fine. We can live with that a little better than the creation of matter and nothing, space and things from absolutely nothing, which is wrong anyways because nothing was created at the Big Bang. So this is an irrational theory. And of course they say, well, we don't know what happened before the Big Bang. Of course you don't. You don't, because that's what you got to answer. If you can't answer that question, your theory is nonsense. It's idiocy. Big Bang creationism is idiocy. The traditional religions are a step ahead at least because they say God made everything. Okay, made nothing and something. Okay, he had his magic wand. Where did God come from? He's eternal. Okay, so they stop you there, but at least they have an answer for that. What are you going to say for Big Bang? That the singularity was eternal? And what is the singularity if not nothing, which is what came out of the singularity? So no, Big Bang is an irrational theory because they cannot tell you what came before. They can't tell you. They can't show you the first frame in the movie, or you might say, well, the first frame was the Big Bang, the explosion. Okay, fine. I want to know the -1 frame, the one that came before the 0 frame. That's the one that they need to explain. They can't explain that. They don't have a theory. They have an irrational explanation for how this universe works. In this case, that it's expanding and so on. Okay, they can't use that because they cannot tell you what came before the Big Bang. That's the question they have to answer. They can't answer that question. Their theory is garbage. So all this stuff that the mathematicians believe in, that they say, oh, Big Bang, and that's when everything started. And we know that for sure because everything's expanding and we take the movie backward and we end up with the singularity. All that's garbage. All of it. 150% of it. If they cannot tell you how the first bit of matter came into being, the mechanism, that's what we want to understand. Not the mathematics of it, not how much time. We don't care about that. We want to know the mechanism of how something popped in from the void from nothing, and how nothing popped in from the void from nothing, because Big Bang created both, nothing and something. Okay, so we can't imagine what they're talking about. That's the issue. Okay, here's now a fellow, he raises an issue, says, Bill Gates has no idea why the ropes don't get knotted. Together, unless we grant him the assumption of magic ropes that just happen to never knot together or cross each other or whatever. This is irrational. I'll use your definition of touch when two objects become one object. Well, at least this fellow learned something. At least he learned that what the definition of touch is. He's learning something at least. As far as why the ropes don't get knotted, we have an explanation for at least one situation. There are several situations. Okay, let's go with one of them. Here's one. Okay, I showed this in the past. This is the construction of the atom and how one atom approaches another by going through the rope itself. Because remember, the rope makes up the atom. Okay, the rope, one thread goes through the center and the other thread goes around. And they come out the other end or in some direction, and they come out as a rope. Okay, so it's not coming out. It's just that the atom is made of the same threads as the rope. There's a single thread in the entire universe that makes up everything. That's the assumption. Okay, so here's one atom approaching another because it's made of the same threads that the rope is made of. Okay, here it is. Okay, so you see one atom is just approaching another one like a bead sliding along the the abacus. Okay, so the bead that goes through the wire of an abacus, it doesn't push on the wire itself. It doesn't collide against it. It just slides through it. In this case, that's a good analogy for what's happening here, more or less. You see that the one thread goes around the atom, the other one goes through, okay, through the center. And so the atom is eating into the rope as it approaches another atom. So in this case, there is the reason the atom doesn't cross that rope is because it's sliding along the rope. Okay, so it needs not cross it. Okay, so and here's another version of that. Okay, here we have fingers of a hand, and again, that's every atom in that hand. I've just showed a few there, and you got to think of them as hydrogen atoms, the simplest atoms, and they're sliding along a single rope that's connecting that. Obviously, there are gazillions of ropes, okay, when that hand approaches the ball. But my point here is, if you have only a single atom sliding along a single rope, that's what's happening. The hand does not have to cross, does not have to cut the ropes, okay? The hand slides along the ropes. The atoms are sliding through the ropes, okay? So there's no cutting across. That's the point that I'm trying to make. So this is one situation, okay? And then what's the other issue? Well, the other issue is this fellow is asking the wrong question. Okay, and so let me remove this for a second here. Give me a second here. So what's happening? The first problem is this fellow has to answer, okay, what do you propose instead? If he proposes particles, do particles occupy the same space? Do particles go through another particle? Okay, so this is the first question he's got to answer. Because if he's going to propose the same thing, then he's got nothing new to add. Okay, that's the first issue. The second issue is that in rational science, under the rope model, okay, we define an object as that which has shape, not as that which you can touch or see. So we don't have to answer the question of touch or see or crossing, two ropes crossing each other. Why? Because touch is not an issue and see is not an issue. These people have touch and see in their brains because that's what they were brainwashed to believe, that everything is touch and see, that an object is that which you can touch and see. So he's got to start before he can even ask the question, he's got to tell us what an object is, what a thing is. And if a thing is that that has shape, then touch and see don't enter the picture at all. He shouldn't ask any question related to touch or see. Now he says, well, how is it that ropes go through each other? Okay, but the issue here is that atoms don't go through each other like they do in quantum. In quantum, everything is possible. A particle can be at two places at once. Two atoms can be at the same place at the same time. They can have two different states, as they call it. So they have all these miracles out there that two atoms can be in one position at the same time. And in what we do in rational science, under the rope model, we say atoms cannot be at the same place at the same time. Atoms have surfaces and they bang against each other. Now, ropes, they are much thinner. You're talking about something unimaginably thin, unimaginably small, and they don't have the properties of touch and see. Specifically in this case of touch, see is not an issue here, I think. They don't have the property of touch. If they don't have the property of touch, it's irrational to say, how did they touch each other? No, they don't have the property of touch. And if they don't have the property of touch, they don't have a problem going right through each other because there is no touch in that world, in that vanishingly thin world of the rope. Okay, this is the model of the rope, but this is made out of atoms, this one. So this is just a model as far as the shape of what we're talking about. That's why we call it a rope. That's about the only property that the rope in the invisible world of Mother Nature's have, the electromagnetic rope. It only has that property, the shape of it. Other than that, it doesn't have the property of touch. I mean, can this rope go through this piece of rope go through that one? No, of course not, because it's made out of atoms. And under the rope model, atoms can't go through atoms. In the religion of quantum mechanics, they can. Two atoms can occupy the same space. Under the quantum model, you should be able to have this rope go through that rope, this piece of rope go through that piece of rope, because they say that, yeah, that can happen in the religion of quantum. In science, no, it can't. You can't have this rope go through that piece of rope. But that's when we're talking about macro world, this type of rope. When you're talking about the micro world, when you're talking about the electromagnetic rope, it doesn't have the ability to touch. So what's the question? The question is, why don't they touch each other? Why do they go through each other? Again, it's not an issue. It's not an issue because they don't have the property of touch. That's not what an object is. An object is that which has shape, not that which you can touch or which can touch something else. So it's the touch issue that's got these people crazy. They're thinking about touch. And yeah, that gets them, because they say, how can it possibly be that Mother Nature works with these things that you can't see or touch? Well, we can't see the air. I mean, why don't you ask that question? Why can't we see the air? Yeah, I don't know. That's the way God made our universe, right? Mother Nature, the devil. Someone made the universe that way, that we can't see the air. I'm sorry. And so go complain there, raise a complaint against Mother Nature. Okay, here's another fellow. He says, energy is change over time. You still don't understand energy. Okay. Yes, work is a concept. Okay. Yeah, he got one right. How do we transfer change? Okay, because if energy is change, right? How do we transfer this thing they call energy? How do we transfer change? And I like the answer he gives. According to you, we kill the observer. So that is a bad question. Yeah, observer has nothing to do with change. We can have change without having any observer. The moon, even before any humans or any life was on Earth, the moon was already changing, moving from one place to another. There was change, at least in location, certainly in form. And so we can have change. It needs no observer. So this poor fellow thinks that you need an observer for change. I don't know where he got that. But again, these are religious people. These are people who were brainwashed to use this word energy to exhaustion, and they can't get away from it. If you destroy the word energy for them, you destroy their life. You just literally destroy their life, because they've been brainwashed to exhaustion to talk about energy. And they use the word energy for everything, and they think they're being rational. And all they're doing is introducing words of ordinary speech like energy, time, field, mass. And they introduce this into physics as if objects, and they just go along. And again, if you challenge that, they say you're doing semantics. That's all. That's the only argument they have, because they have no way of answering. All this guy did was elude the question, because you can't transfer change, because change is not a physical object, not because it has anything to do with observers. But explain to him. I mean, the guy has probably a peanut brain. My God. Okay, Paul says, energy is a concept. Yeah. You have to reference manifestations of the concept. Reference manifestations of the concept. Well, I don't know how a concept can manifest anything. Concept is a concept, like it says there, and so you cannot talk about manifestations, meaning actions. I guess that's what he's saying. What do you mean manifestations? Like moving? Is that what you're saying? Concepts are moving? But then he says, burning wood to make heat is a transfer of energy. So he starts by saying energy is a concept, and he ends by saying transfer of energy. How do you transfer a concept? Period. That's the question you got to answer. You have to identify the object. I can transfer the ball from A to B. That's called transfer in physics. It's literal. No guessing, no wordiness or anything. Transfer is directly. This is transfer. Transfer a ball from A to B. That's called transfer. Can you do that with energy? Can you transfer energy from A to B? In order to explain that in physics, not in religion, but in physics, you need to make energy appear. You need to show us energy. You have to draw a picture, take a snapshot, show it on the frame, on the film. Show me energy before you transfer it. That's the way it works. And you can't say, well, that's semantic. No, 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 no. Not in physics. Physics, literal. You got to make the picture, then you can transfer. Otherwise, you can't use the word transfer. But see, these people talk about transfer so much that later on they actually believe energy is a physical object that you can transfer. And all they're doing is an accounting procedure. You didn't transfer money because money is a concept. You can't transfer money, even through through Western Union. That's not called transfer. That's in ordinary speech. You can't transfer concepts. You didn't transfer money through the wire. Money, yeah, you got a dollar bill you can transfer, but that's not what they transferred. They did an accounting procedure and they call it transfer, and people say, oh, we transferred money. And these people are talking in the same way. They say, we transferred energy. Yeah, from the assets to the liabilities. You transferred energy. So what did you do? Did you transfer energy through the wire? Did you turn this smoke into something solid? I mean, what did you do? Show me the picture. Show me the things. Don't talk. Don't give me an equation. Show me the movie of something there called energy that transformed from, I don't know, potential to kinetic or chemical to kinetic. Then you can talk about transfer of energy. Otherwise, it's just an accounting procedure that has no meaning whatsoever in physics. With that, I'll see you next time, hopefully on Sunday. I'll probably be traveling this weekend, so I don't know if I'll see you